sulfur or sulfide ore. Burning sulfur or sulfide ore. Burning okay. Our preparation is a burning sulfur or sulfide ore. SO2 preparation. Burning sulfur or sulfide ore. Sulfides treated with H2SO4. Sulfides treated with H2SO4 or HCl. Sulfides treated with H2SO4 or HCl. So SO3 plus H2SO4 gives what? Na2SO4 plus H2O plus SO2. Okay. Na2SO3 reacted with the HCl. So it gives what? 2NaCl plus H2O plus SO2. Okay, but sulfides are treated with the H2SO4 gives what? SO2. Sulfides treated with H2SO4 or HCl. Okay, preparation. Properties. Like colorless, pungent smelling gas. Colorless, pungent smelling gas. Colorless, pungent smelling gas. Colorless, pungent smelling gas. Okay, what about the solubility in water? Freely soluble in water. Freely soluble in water. SO2 plus H2O gives water. H2SO3. Sulfuric acid. Freely soluble in water. Catalytically oxidizes to give water. Catalytically oxidizes to give water. SO3. Catalytically oxidizes to give SO3. Acidic nature or basic nature? Basic or acidic? Acidic or basic? Basic or acidic? Basic acidic acidic, which is the most acidic oxygen family? SO2, SO3. Adil first one SO3. Water, give water. Sulfurous acid. So it is an acidic oxide or basic oxide? Acidic oxide. So being acid neutralized by water. Base. Neutralize base. Being acid neutralize base. Being acid neutralize bases. Okay, excess SO2 is present, forms what? Sodium bisulfite. Okay, so that is Na2SO3 plus SO2 plus H2O gives what? 2NaHSO3. Like our carbonates and bicarbonates. Carbonates in the presence of excess CO2 gives what? Bicarbonates. Same. Okay അല്ലേ? അല്ലേ? SO2 plus Cl2 gives SO2 plus Cl2 gives what? SO2 Cl2. What is SO2 Cl2? Sulfuryl chloride. What is SO2 Cl2? Sulfuryl chloride. അല്ലേ? What is thionyl chloride? SOCl. Okay അല്ലേ? എടുത്തല്ലോ. And the SO2 is reacted with PCl5. PCl5. What product formed? 2 Cl come here and 1 oxygen. So gives what? POCl3 and SOCl2. That is thionyl chloride. Thionyl chloride. Hello. Okay, SO2 plus 4 and so what is the stable oxidation state? Plus 6, which is the most stable oxidation state for sulfur? Plus 6. So undergoes what? Undergoes what? Oxidation. So act as what? Act as a reducing agent. SO2 can act as a reducing agent. SO2 can act as a reducing agent. So here moist SO2 act as reducing agent. Moist SO2 can act as a reducing agent. That is SO2 plus 2H2O gives H2SO4 plus 2S plus agent due to decomposes അല്ലെങ്കിൽ releases what? Releases nascent hydrogen. അല്ല, releases what? Nascent hydrogen. Okay. The moist SO2 act as a reducing agent due to reduces to give nascent hydrogen. അല്ലെങ്കിൽ releases nascent hydrogen. അല്ല, nascent oxygen ആണെങ്കിലോ oxidizing agent. This is nascent hydrogen. Okay. SO2 plus H2. So what is this? Moist SO2. Moist SO2. Hello, moist SO2. So this X2 becomes what? 2HX. And X2 becomes 2HX and plus H2SO4. So what are the X's will be? X is equal to fluorine or chlorine, not bromine and iodine. Alla, not bromine and iodine. Bromine and iodine have എന്താണ്? HX converted into what? Br2 and EF2 അല്ലെങ്കിൽ I2. H2SO4 plus 2HX. So it acts as a what agent? Reducing agent. So it can reduces a layer. So it can reduces. It can reduces. So it can dechlorize water. It can dechlorize KMnO4. It can dechlorize water KMnO4. So that means KMnO4 is converted into water 4 plus water MnSO4. So that means 2. So here it is 2. So plus 3H2SO4. 3H2SO4. Again, so that means KMnO4 is converted into water K2SO4 and MnSO4. So what is the oxidation state of manganese here? Plus 7. Okay, so here and it is a 2 plus. Okay, so undergoes water reduction in the presence of water moist SO2. Okay, അപ്പോൾ ഇവിടെ റിയാക്ഷൻ വരുന്നത് നോക്കി മക്കളെ SO2 plus H2O plus monoxygen gives what? H2SO4. So this is the balancing equation. SO2 plus H2O gives a H2SO4. So here KMnO4 is converted into dechlorize KMnO4 by it converted into what? K2SO4 and MnSO4. So how many K is here? 2K. So how many KMnO4 here? 2 KMnO4. So how many MnSO4 should be here? 2. So what is how many SO4 is used here? 3. So what is 3 H2SO4? Okay. So how many oxygen is used here? That is plus 3H2 plus 3H2. Okay. So what is the total amount of oxygen is used? 2, 3, 12. That is a 20. Okay, here 4, 8 and 3, 12 and 50. Okay, so how many oxygen is required here? 5. This reaction is multiplied with what? 5. This reaction is multiplied with the 5. That is 5SO2, 5H2O, 5 monoxygen and 5H2SO4. Okay. So there is 5H2SO4 and 3H2SO4 here. So there is 2 KMnO4 plus 5H2SO2 plus 5H2SO4 is 5H2O gives 3H2SO4. So basically the reaction is not that much important. We have to understand dechlorize water KMnO4. Okay, that means KMnO4 plus 7 is converted into water 2 plus. So that is K2SO4 and MnSO4. Okay, that is for them. Okay, so this reaction is multiplied with the 5. That is 5SO2 plus 5H2O plus 5 monoxygen gives 5H2SO4. Okay, so balance this equation. That is 2 KMnO4 plus 3 5SO2 plus 5H2O gives 5 oxygen and 5 monoxygens are cut. Okay, gives what? K2SO4 plus 2MnSO4 plus 3. There is 3 and 5 here. There is 2H2SO4 plus 3H2. Okay, this is a balanced equation. Dechlorize the KMnO4. That means dechlorize acidified KMnO4 എന്ന് പറയാം. Dechlorize acidified KMnO4. Okay, so KMnO4 is get reduced into water. അവിടെ 3H2 അല്ലേ? 3H2O ഇവിടെ എത്ര H2O? 5H2O അല്ല, 3H2O കട്ട് 5H2O കട്ട് പ്ലസ് 2H2O. ഓക്കെ, 2H2. Dechlorize acidified KMnO4 by converting K2SO4 and MnSO4. Okay. Okay, so here also K2Cr2O7. So what is oxidation state is plus 6. What is oxidation state here? It is plus 3. Undergoes what? Reduction in the presence of what? Moist SO2. So SO2 acts as a what? Reducing agent. Balance the equation. Okay, K2Cr2O7 into Cr2SO4 thrice and K2SO4. So how many SO4 is used? That much amount of H2SO4 is required. If it is 2 H2SO4, 2 H2O will be there. 4 H2SO4, 4 H2O will be there. And last finally count the number of oxygen involved in both sides. Okay. So here K2Cr2O7 gives what? K2SO4 plus what? Cr2SO4 thrice. It is the green colored one. Green colored one. So how many H2SO4 is used? 4. So it is plus 4 H2SO4. So how many H2O will be here? 4 H2O will. And count the oxygen here. 7 and 6. Next here 4, 12 and 4, 20. How many oxygen is required here? 3 oxygen is required. Okay, so this reaction is multiplied with the 3. Reaction is multiplied with the 3. Okay, so what is the equation will be? 3 SO2 plus 3 H2O plus 3 monoxide gives 3 H2SO4. So 3 monoxide from the both sides are cut. Okay, and 3 H2O here and 4 H2O there. So 3 and 3 there will be 1 H2. So what is the final? A2 plus 3 SO2 plus 4 H2SO4 gives 3 H2SO4, 4 H2SO4. So 1 H2SO4. Okay, 3 H2SO4, 4 H2SO4. So 1 H2SO4, 3 H2O and 4 H2. So here we will have 1 H2. K2SO4 plus Cr2SO4 thrice plus 1 H2. So this is the final equation. Okay, so this is the orange red crystal. What is the color of orange K2Cr2O7? Orange red crystal. KMnO4 purple color. Cr2SO4 thrice green colored. CrO2 Cl2
red orange.
red vapors, chromyl chloride അല്ല. Okay, oxygen family completed. അല്ലേ, നൈട്രജൻ ഫാമിലി, ഓക്സിജൻ ഫാമിലി. ഇനി വന്ന് ഹാലജൻസ് ആൻഡ് ഇനേർട്ട് ഗ്യാസസ് അല്ലേ. ബിഗ്ഗസ്റ്റ് ഫാമിലി നൈട്രജൻ ഫാമിലി, സ്മോളർ വൺ ഓക്സിജൻ ഫാമിലി, അതുക്കും സ്മോൾ അല്ലേ. ബേസിക്കലി മേജർ ടോപ്പിക്സ് എന്ത് ചെയ്തു, കംപ്ലീറ്റഡ് അല്ലേ. ബോറോൺ ഫാമിലി, കാർബൺ ഫാമിലി, നൈട്രജൻ ഫാമിലി, ഓക്സിജൻ ഫാമിലി. ഓക്കെ ആണല്ലോ, സെറ്റായാ? ஓகே, ஆக்சிஜன் ஃபேமிலி ஜஸ்ட் பாருங்க, moist acid, ഓക്കെയാണോ അല്ല. ഹാലജൻസ് ഗ്രൂപ്പ് 17 ഹാലജൻസ്. ഗ്രൂപ്പ് 17 ഹാലജൻസ്. ഹാലജൻസ് 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 ഗ്രൂപ്പ് 17 അല്ല. ആരോഗ്യ മക്കളെ which are the elements? F2 fluorine, chlorine, bromine, iodine, astatine അല്ല. അസ്റ്റാറ്റിൻ മറ്റേ ഹാലജൻ അല്ലേ, വേണ്ട അറിയാതെ. ഫ്ലോറിൻ, ബ്രോമിൻ ആൻഡ് അയോഡിൻ അതൊക്കെ വെച്ചു. ഓക്കെ അല്ല. ഫ്ലോറിൻ ഈസ് എക്സിസ്റ്റ് ആസ് ഫ്ലൂറൈഡ്സ് അല്ല. ഫ്ലോറിൻ ഈസ് എക്സിസ്റ്റ് ആസ് ഫ്ലൂറൈഡ്സ്. പോയിന്റ് ഓർഡർ ഒക്കുറൻസ്. ഫ്ലോറിൻ ഈസ് എക്സിസ്റ്റ് ആസ് ഫ്ലൂറൈഡ്സ് അല്ല. CaF2, Na3, AlF6, Ca9, PO4, 6, CaF2 അല്ല. വാട്ട് ഈസ് CaF2? ഫ്ലൂർസ്പാർ. വാട്ട് ഈസ് Na3, AlF6? Cryolite. What is CA9PO4 6CF2? Fluoroapatite. Allah. Fluorspar. Calcium fluoride. Fluorspar. Cryolite. Fluoroapatite. Allah. Both are cryolite and fluoroapatite. CF2 is fluorospar അല്ലെങ്കിൽ fluorspar. അല്ലേ? Present in teeth fluoroapatite അല്ലേ? Tooth decay already discussed. Present in teeth അല്ലേ? Chlorine and bromine exist as what? Alkali and alkaline earth metal halides. Okay, Cl and Br exist as Cl and Br exist as Cl and Br exist as halides of alkali and alkaline earth metals. Halides of alkali and alkaline earth metals. Mainly present in where? C, salts, NaCl, KCl, complete blur evideya? C, mainly present in C. Which is the most abundant halogen? Chlorine. Most abundant halogen is chlorine. Chlorine is the most abundant halogen. Iodine is exist as a sodium iodate. 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 Okay, that means Na plus and what? IO3 minus. Okay. India. Atomic radius down the group increases. Ionization energy down the group decreases. Electronegativity down the group decrease. First one, fluorine. Fluorine is the most electronegative element. Okay, what about the electron gain enthalpy? Electron gain enthalpy down the group becomes less negative, but Cl have greater than fluorine. So what is the order? Fluorine, chlorine, bromine, iodine. So here normally like this. Okay, but here we have what? An exceptional nature. So which have higher? Cl have a higher. So the same way electron affinity decreases. But Cl greater than F. The same way, that is so what do you mean by electron affinity and electron gain enthalpy? Both are same. One and the different point of view of thermodynamics. One is from the surrounding point of thermodynamics. Okay. Metallic character. All are non-metals. Fluorine and chlorine are gas. Bromine is a iodine is a solid. All are non-metals. Melting point and boiling point. down the group increases. Melting point and boiling point down the group increases. Okay. So bond dissociation energy. Bond dissociation energy of fluorine is lower than of chlorine and bromine. So what is the reason will be? That is fluorine and fluorine. So this is strong electronegative, strong electronegative. So high electronegativity bond becomes close. So there will be a repulsion of electrons. So these bonds are very weak. So here the bond dissociation energy of fluorine is lower than what? Chlorine and bromine. And what about the reactivity down the group? Reactivity. Then iodine. Okay. Their reactivity is due to what? Electronegativity. Which is more electronegativity? Fluorine. So reactivity down the group decreases. Okay. Reactivity down the group decreases. Normal bond dissociation energy. Reactivity, melting point, boiling point, metallic character, electronegativity, ionization energy, atomic radius, electron gain enthalpy or electron affinity. Okay. In other words, X2 halogens converted into what? X minus. So that means 0 to minus 1 undergoes what? Reduction. So they act as what? Oxidizing agent. So halogens can act as a good oxidizing agents. Halogens are act as oxidizing agents. Halogens can act as oxidizing agents. Halogens act as oxidizing agents. Like F into F minus 1, Cl into Cl minus 1. Okay, so they are undergoes reduction, so act as a oxidizing agent. Okay. Okay. So here oxidizing action in aqueous state. Oxidizing action in aqueous state. That means here we have X2. Okay. So X2 undergoes what? Bond dissociation. So it gives what? X. And it undergoes what? Electron gain enthalpy or what? Electron affinity. Gives what? X minus. X minus converted into what? X minus aqueous. So this enthalpy is called enthalpy of hydration. And hydrous substance converted hydrogen. So here we have a bond dissociation energy Cl2 greater than what? F2. Electron gain enthalpy of Cl2 greater than what? F2. Okay, so the total enthalpy is negative. So that is delta H total is negative. Delta H total negative. So which is more stable, product or reactant? Which is more stable or reactant? Product. Exothermic reaction. Every body has a tendency to minimize their energy and to become more stable. So the substances are tendency to what? Reduce their energy. So that means reduce their energy means evolution of energy. So the energy evolving process, the products are more stable than reaction. So the total enthalpy is negative. X minus is more stable than what? X2. So that means X undergoes what? Fast reduction. So it acts as a good oxidizing agent. Okay, so if delta H is negative, that is X is more oxidizing. Delta H total is negative, X have a high oxidizing power. So what is the bond dissociation enthalpy is positive or negative? Bond dissociation energy endothermic or exothermic? It is a endothermic. Energy required for breaking of bond. What is electron gain enthalpy? It is the energy released or energy required. It is the energy released. And here is the enthalpy of hydration. It is exothermic or endothermic? Exothermic or endothermic? Exothermic. Water comes in our body, feels cool or heat? Cool. That means energy is absorbed or released? Energy is released. Heat goes and we feel cool. So at what condition the delta H total will have a higher negative value? So here electron gain enthalpy is largest for Cl2 than what? Fluorine. But enthalpy of hydration is very higher for fluorine than what? Chlorine. Due to enthalpy of hydration and sizes are inversely proportional. So fluorine have a very smaller size, so it has what? Very high enthalpy of hydration. So which is the strongest oxidizing agent here? Fluorine. Due to why? High enthalpy of hydration. Even it has low electron gain enthalpy and bond dissociation energy than chlorine. Okay, so here therefore here fluorine is the most oxidizing agent. Even it have low electron gain enthalpy and bond dissociation energy than Cl2. But it has what? But it have very high enthalpy of hydration due to small size. Okay, so what is the oxidizing power? Is oxidizing power F2 greater than Cl2 greater than Br2 greater than I2. Okay, good. Okay, so which is the most strongest oxidizing agent here? Fluorine. Okay, so which is a fluorine can oxidize what? Cl, Br and iodine. So Cl can oxidize what? Br and iodine. Br can oxidize what? I2. So here F2 converted into what? F minus in the presence of what? Cl minus, Br minus and I minus, which have larger tendency to becomes negative charge. Fluorine have more than what? Cl, Br and I. And the same way, that is Cl2 can oxidize Br2 and I2. So here Cl2 plus 2x minus gives what? 2Cl minus plus x2. Here x is equal to Br and iodine. Br2 can oxidize what? I2. So here Br2 plus 2I minus gives 2Br minus plus I2. So fluorine can oxidize Cl, Br and Ia. So which is the strongest oxidizing agent in halogens? Fluorine. So fluorine can also oxidize, അല്ലെങ്കിൽ fluorine even oxidize what? Water also. So fluorine can oxidize what? Water. F2 can oxidize water. So that is 2F2 plus 2H2 gives 4F minus plus 4H plus. Fluorine can oxidize water. Fluorine can oxidize water. Fluorine can oxidize water. Fluorine can oxidize water. Okay, so it is Cl2 and Br2 reacting with water gives HX and HOX. HX and HOX is HCl. So that means halic acid. So what is HOX? Hypohalous acid. Okay, so that is Cl2 and Br2. That is Cl2 plus H2O gives what? HCl plus HOCl, hydrochloric and hypochlorous. Hypohalous. Cl2 and Br2 reacting with the water gives HX and HOX. Hydrohalous and hypohalous. Hydrohalic. The reaction of iodine with the water is non-spontaneous. Reaction of iodine with water is non-spontaneous. Reaction of iodine with the water is a non-spontaneous reaction. Not feasible reaction. Not spontaneous means not feasible reaction. Delta G will be, delta G, change in free energy will be positive. Okay, general properties of halogens. So these are the general properties of halogens. So fluorine can oxidize water. Cl2 reacting with water gives water HX and HOX. Reaction of iodine with water is a non-spontaneous one. Okay, oxidation state. Oxidation state. So what are the common oxidation state will be? Plus 7, plus 5, plus 3, plus 1 and minus 1. So generally shows what? Generally shows minus 1. Fluorine only shows what? Only shows minus 1 except in HOF. Except in HOF. In HOF it shows what? Plus 1 oxidation state. Okay, so basically fluorine only shows what? Minus 1. Generally shows minus 1 oxidation state. Fluorine only shows minus 1 except in HOF. Fluorine only shows what? Minus 1 oxidation state except in HOF. So what are the common oxidation state of halogen family? Plus 7, plus 5, plus 3. So what general oxidation state is? Minus. Shows minus except in compound HOF. In HOF it shows what? Plus 1 oxidation state. Reaction with the hydrogen. Reaction with the hydrogen gives what? 2HX. So what are the HCl, HBr and HI. Okay. Thermal stability down the group decreases. That means MH bond becomes what? Weaker. HX bond becomes weaker. So they are reducing power down the group increases. Reducing power down the group increases. So that means which are act as a good reducing agents? HBr and I. So they undergoes what? I2 and Br2. Simple. അല്ലേ I2 and Br2. HF ആണെങ്കിലോ it is not a good reducer. It can't reduce anyone, but it can reduce KMnO4, K2SO4 അല്ലെങ്കിൽ Cr2SO1 etc. Okay, next one, boiling point down the group increase, but highest for presence of hydrogen bond. അല്ല boiling point down the group increase, but highest for HF due to the presence of hydrogen bond. Okay, nature down the group in the basic nature of hydrogen down the group decreases. NH3 more basic, pH3 AH3 SbH3 BH3 basic nature decreases, acidic nature increases. So here acidic nature down the group increases. Okay, so which is more acidic here? HI, HBr, HCl and HF. So which have weaker H bond? HI. So which give easily H plus in aqueous solution? HI. So more acidic nature. Basic nature decreases and acidic nature increases. In case of what? Hydrides. What is the structure of HX will be? What is the structure of HX? What is the structure of HX? What is the structure of HX? What is the structure? Structure, shape. Linear, single bond. So what is the structure is a linear. What is the total pair of electrons? 4. So what is hybridization will be? sp3. One bond pair and 3 lone pair. Total pair of electrons. So what is hybridization will be? sp3 hybridization. Linear with sp3 hybridization. Reaction with oxygen. Reaction with oxygen. What is the charge of oxygen? -2. We have a +1, +3, +5, +7. So they give us a number of what? Oxides. But fluorine only gives what? O2, F2 and OF2. Others can give a number of oxides. So they give a number of oxides. They give a number of oxides. But fluorine only gives O2, F2 and OF2. Fluorine only gives OF2 and O2, EF2. Reaction with the halogen. Okay. O2F2, OF2. Reaction with the halogen. So halogens are reacted with the other halogens. Forms what? Inter-halogen compounds. So halogens reacted with the halogens gives what? Inter-halogen compounds. So they gives inter-halogen compounds. Interhalogen compounds. Interhalogen compounds. So what are the interhalogen compounds? So what is the charge of X dash will be -1. So here it is a +1. Here it is -1 and it is a +3. So 3 halogens are combined. 5 halogens are combined. 7 halogens are combined. So the X dash means X with X dash. X dash. Okay. So there is lone pair and lone pair. What is the structure is a linear, and what is the hybridization is sp3. That is total pair of electrons is 4. Xx dash. So what is the total number of bond pair is equal to bond pair is equal to 3. So 3 out of 7, 3 are participated in bonding. So there will be 4 electrons. So that means the lone pair is equal to what? 2. So what will be the geometry? sp3d2. What is the hybridization will be sp3d hybridization. Okay. So what will be the geometry? Trigonal bipyramidal with 2r what? With 2r lone pair of electrons. So what will be the structure? Bend T shape or T shape. Okay. So here that is X dash with the 2 lone pair of electrons with the bend T shape. Okay. Next one Xx 5 dash. Okay, how many bond pair? 5. Bond pair is equal to 5. So out of 7 electron, 5 are participated in bonding. So what will be the total number of lone pair of electrons will be is equal to 1. So what is the total number of electrons? 6. Okay, 6 means what is the hybridization will be? sp3d2. What is the geometry will be? Octahedral with 1 what? Lone pair of electrons. With 1 what? Lone pair of electrons. So what is the shape will be? Square pyramidal. Okay. So that is X dash with the lone pair of electrons. Square pyramidal. Xx 7 dash. What is the total number of pair of electrons? 0. So what is the hybridization will be? sp3d2 hybridization. And what is the geometry will be if it is 7? sp3d3. What is the geometry will be? X dash and X dash. So what is structure? Pentagonal bipyramidal. Pentagonal bipyramidal. Pentagonal bipyramidal. Interhalogen compounds. No. Appa kadole. எப்போ நீங்கள்கிட்ட கேட்கும்போதும் இந்த வந்து நம்பர் ஆஃப் பேர் ஆஃப் எலக்ட்ரான்ஸ் பாண்ட் பேர் லோன் பேர் தெரியுமா? ஆமாம் சார் தெரியும். 4 பாண்ட் பேர் வித் 0 லோன் பேர் അല്ല ഒക്ടാഹെഡൽ ടെട്രാഹെഡൽ മാങ്ങാത്തൊലി ഉണ്ടപ്പൊരി തേങ്ങാക്കൊല അല്ലേ? എന്നാ ഒന്നുമേ കറക്റ്റാக சொல்லாது അല്ലേ? ஆனால் தெரியும் லோன் பேர் பாண்ட் பேர் நம்பர் பேர் ஆஃப் எலக்ட்ரான்ஸ் தெரியும் சார், நல்லா தெரியும் இல்லை, ஆனால் சொல்ல முடியாது இல்லை. ഓക്കെ അഞ്ചാ sedaya sedai lah sedaja lah sedaidu sir sedaidu lah set avale sir enna pandra set avale nanu ivlo varju try pannita onnume set avale sir enna pandra la സെറ്റ് ആവട്ടെ അല്ലേ? സെറ്റല്ലേ സെറ്റല്ലേ? ഇല്ല സാർ ഞാൻ സെറ്റ് ആവില്ല സാർ. ഓക്കെ എടേ എടാ നോക്കിയ ടോട്ടൽ പെയർ ഓഫ് ഇലക്ട്രോൺസ് represented by n. total pair of electrons. Okay, total pair of electrons 2 3 4 5 6 and 7. Okay, so what will be the geometry? Okay, so what will be the geometry? A, B and B. So what is the geometry is linear. And 3 A, B, B and B. So what is the geometry? Trigonal planar. 4 A, B, B, B and B. So what is the geometry? Tetrahedral. And 5 A, B, B, B. ഇതിങ്ങനെ ചിത്രം കാണിക്കണം, ഇഷ്ടംപോലെ സ്ഥലമുണ്ട് അല്ലേ? 3 okay 4 B. So what is the geometry? Tetrahedral. Okay അല്ലേ? If it is total pair of electrons is 5, geometry will be A, B, E, trigonal by pyramidal. Okay, if it is 6, total pair of electrons 6, so it is A, B, 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 and B. So what is the structure will be? Octahedral. Okay. If it is 7, so it is A, B, 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 B. Pentagonal bipyramid. So what is the hybridization state will be? Is the hybridization? Yes. sp2, sp3d, sp3d2 and sp3d3. അതൊന്ന് കൊടുത്ത് കുറേ നേരമായി. Total pair of electrons. So what are the different geometries we have? Linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, pentagonal bipyramidal. Okay അല്ലേ? Okay, so it is number of pair of electrons is equal to 2. Number of pair of electrons is equal to 2. Over here bond pair is equal to 2 and is equal to 0. Lone pair is equal to 0. So what is the structure? Linear. And number of pair of electrons is equal to 3. Number of pair of electrons is equal to 3. Bond pair is equal to 3 and lone pair is equal to 0. So what is the structure? Trigonal planar. Okay, and if it is a bond pair is equal to 2 and lone pair is equal to 1. So what will be the structure? Will be A, B with the lone pair of electrons. So angular or V or bend shape. So what is hybridization? Again it is a sp2. Hybridization is a sp. Okay, and the same way n is equal to 4. So what is the geometry or shape? Tetrahedral. 3 and lone pair is equal to 1. So what the structure will be? A, lone pair, B and B. So what is the structure? Is a pyramidal. 4 bond pair with 1 lone pair. And third one, and bond pair is equal to 2, lone pair is equal to 2. So that is pair and bond pair. So what is the structure? Bend, V or angular. Okay, and next one, n is equal to 5. One bond pair is equal to 5 and lone pair is equal to 0. So what is the structure? By pyramidal. Next one is bond pair is equal to 4 and lone pair is equal to 0. So that is A, B and B and B. So one is a lone pair of electron. So what is the shape? Is a seesaw geometry. Okay, and next one is bond pair is equal to 3 and lone pair is equal to 2. So what is the shape? Will be A, B and 2 lone pair of electrons. So what is shape? Will be T shape or bend T shape. Okay, അതേപോലെ തന്നെ n is equal to 6. bond pair is equal to 6, lone pair is equal to. അപ്പോൾ അതേപോലെ തന്നെ ഇവിടെ bond pair 2, others all are lone pair. The lone pair. So what is structure? Will be linear. Structure will be linear. And bond pair is equal to 6 and lone pair is equal to. So what is the geometry? Hedral. And bond pair is equal to 5 and lone pair is equal to 1. So what is the structure? A, B and B with the lone pair of electrons. So what is structure? Will be square pyramidal. Okay, and if it is bond pair is equal to 4 and lone pair is equal to 2. So what is structure? Will be A, B and 2 lone pairs. So what is the structure? Will be square planar. Okay, and n is equal to 7. So bond pair is equal to what? Bond pair is equal to 7 and lone pair is equal to 0. So what is the geometry? Is a pentagonal pyramidal. And bond 6 and lone pair is equal to 1. So lone pair of electrons. So what is the structure? It is a octahedral. So that means a regular octahedral. So it is a irregular octahedral due to the presence of a lone pair of electron. So the structure is called distorted octahedron. Okay, good. This is the geometry, shape, hybridization, bond pair, lone pair. PCl5, what is the valence electron of phosphorus? 5. So 5 are bonding, 5 bond pair, 0 lone pair. So what is the structure will be? Trigonal bipyramidal. CCl4, 4 valence electron, 4 are participated in bonding. So bond pair is equal to 4, lone pair is equal to 0. So what is structure will be? H2O, 2H, upper 2 bond pair and 4 electrons, that means 2 lone pair. So what is structure will be? Bend or angular structure. Okay, IF7, IA, pentagonal bipyramidal. Okay, so which shows the seesaw geometry, one pair and 3 bond. So total valence electrons 5. This is 1, 2, 3, 4, 5 and 6, which shows the 6 electrons. Which electron? Oxygen family, SF4. Okay, 4 bonds, 1 lone pair. 1 lone pair. Okay, which shows here how many electrons? 1, 2, 3, 4, 5, 6, 7, which have 7 electrons, halogens. So which 3 bond? So there is XX 3 dash, 3 bond pair and 2 lone pairs. Okay. Distorted octahedral. How many valence electrons should be here? 1, 2, 3, 4, 5, 6, 7, 8. So which the element will be? Inert gas with 4 bond pair, 6 bond pair. Example HCF6. Okay, so what is the structure of HCF4 will be? HCF4, how many bond pair? 4 bond pair. So what is the valence electron? 8 minus 4, so that is 2 lone pair. So bond pair is equal to 4 and lone pair is equal to 2. So what is the structure will be? Total pair of electrons 6 total pair of electrons 6 with 2 lone pairs. It is square planar. What is the hybridization? sp3d3 sp3d2. Okay, so what is the structure of HCF2 will be? HCF2 2 bond pair, out of electron 2 are participating in bonding. So there is a 6 electron, that means a 3 lone pair with the 2 bond pair. So what is structure is linear structure. What is hybridization will be? sp3d2 hybridization. Okay. பி பிளாக்கில் வெரி இம்பார்ட்டண்ட் ஜாமெட்ரி, ஷேப்பு, லோன் பேர், போண்ட் ஆங்கிள். நான் இது நிறைய தடவை கேட்டேன், தெரியுமா தெரியுமா தெரியுமா, அப்போ எல்லாம் தெரியும் சார். ஆனால் நான் கேட்கும்போது மற்ற டெட்ரா ஹே ஹோ டா டே டா டூ டா இல்லை அதே சொல்லியிருந்தேன், நான் எப்போ இது சொல்லியிருக்கோம். സെറ്റായോ? സെറ്റല്ല? ഓക്കെ. ആ ഓക്കെ. അപ്പോൾ അത് കഴിഞ്ഞു. നമുക്ക് ഡബിൾ ബോണ്ട് ഇല്ലേ? ഡബിൾ ബോണ്ട് കൺസിഡേർഡ് ആസ് എ സിംഗിൾ ബോണ്ട് അല്ല. ഹൈബ്രിഡൈസേഷൻ എടുക്കുമ്പോൾ അല്ലെങ്കിൽ ട്രിക്കായിട്ട് ഹൈബ്രിഡൈസേഷൻ എടുക്കുന്ന സമയത്ത് SO3 that is SO3 അല്ലേ? So what is the total bond pair of 3? So what is the lone pair of electrons is equal to 0 അല്ലേ? So what is the geometry? Trigonal planar അല്ലേ? So what is hybridization will be? sp2 hybridization SO2 അല്ലേ? So what is the geometry? Trigonal planar. What is the shape? Angular or bend or V shape. What is hybridization? sp2 അല്ലേ? 3 total pair of electrons 3. Okay അല്ലേ? And the same way XCOF2. So XCF അല്ലേ? So what is the total bond pair of electrons is equal to 3. Okay അല്ലേ? 1 2 3. So how many valence electrons? 8. So out of 8 4 are participated, so there will be 1 2. So lone pair of electrons is equal to 2. So what is the geometry will be? That is what is the geometry? Trigonal bipyramidal. So what is the geometry? Trigonal bipyramidal. So that is XC and with the 2 lone pair of electrons alla. Okay. Two lone pair of electrons. Again, 2 lone pair of electrons. So there will be different possibilities of structures will be. Allah. XCO F2.